Greetings, fellow grade 10s. It's Mr. Hlaja again. Look, welcome to Back to Basics, and we are still looking at quantitative aspect of chemistry, right? Now let's try and answer this question and see in terms of what is required of us in here. Now, basically, they say the empirical formula of a certain compound is to be determined. Now, on analysis of a sample of the compound, it was found that it contains 40% of your carbon, 6.6% of your hydrogen, and 3.3% of your of your oxygen. Now, the first question is define the term empirical formula, right? Now, isn't it that we know that empirical formula is basically the simplest ratio, the simplest whole number ratio of an atom in a compound, right? So before we define it, let's try and start here. Remember, this is 8.1.1. Now, let's say I give you this, right? Let's say you are having this, right? Now, isn't it that the simplest ratio of these can be still be written as C, and then this is going to be H to the power 4, right? So which means now this right here, it is going to be the empirical. Now this is going to be the empirical formula, right? This is going to be your empirical formula, while this one now here now becomes your what? Your molecular formula, right? This is going to be your molecular formula. So which means, can you see that this is going to be the simplest whole number ratio that still represent your what of a compound, because this is your compound, but this one, it is written in its simplest ratio, right? Yes, I just wanted to highlight that. So now, therefore, how do we define it? We are saying now it is the simplest. This is going to be the simplest whole number ratio, the simplest whole number ratio, of atoms in a compound, right? So this is going to be basically your your empirical formula. Now let's look at now your 8.1.2. Now, in this case, this question basically, now it requires you to determine the empirical formula of the compound, and it wants you to show all the calculations, right? Now, what is it that you are going to do here? Now, the first thing that you need to understand is that now, if you are given these percentages, right? Now, remember that the 100%, remember all these percentage, they are going to represent the 100%, right? And we are saying now these 100% can also be converted into 100 grams of mol, right? So which means now from here, now these percentages that you are given, you are going to start now by converting it, or by converting them into what? Into the mass, or in terms of grams. We are assuming the 100% of grams to be now the 100 grams of your sample, right? And then you're going to you are going to then convert all the percentages into grams. Are we together? Now let's see in terms of what is it that you are going to do. I'm going to start here. Now we are going to start. Let's start now with your with your carbon here. So we are saying, firstly, now we are going to start by converting the 40% of carbon. Remember, you are given that your carbon is given by what? It is given by 40%. You are going to convert this 40% into what? Into 40 grams, right? So which means that the carbon is going to be now the 40 grams sample. And now the next step that you're going to do, you're going to look at what is going to be now your molar mass of your carbon. And remember that your carbon, it is given by 12. So this is going to be 12 grams per mole. This is going to be 12 grams per mole that you are going to have here. And now, what is it that we are going to do after that? Now, after we've calculated both of these things, now we are going to say, look, now we are going to look for your mole of your carbon. Now, right, you're going to look for the mole of your carbon. And remember that how do we then calculate the mole? The mole, it's mass over your molar mass. And what is the mass? Already the mass, we have the converted mass, which is the 40 divided by 12, right? So which means now your mole of your carbon that you are going to have in here, it is going to be 3.3 mole. This is going to be 3.3 mole, right? Now this is going to be 3.3 mole. So we are going to do the same thing. Let's get another nice color. We are going to do the same thing with your what? We are going to do the same thing with your hydrogen. So we are going to say, look, your hydrogen, it is given by 6.6%. And what is the 6.6%? You are going to convert this into grams. So this is going to be 6.6 grams, right? Now that is going to be your the grams. And then the next thing that we are going to do now, we are going to say, look, now your molar mass of your hydrogen, it is given by what? It is 1 gram per mole. So we are going to write this as 1 gram per mole. And after that, now we are going to come back and use the molar formula, and then we are saying, what is the mole of now our hydrogen, right? So this is going to be what? Remember, the mole, it's a molar mass, or rather the mass over the molar mass. So what is the mass that you were given there? It's 6.6 grams over your 1. Isn't it so? And which means this is going to be still the same as 6.6 what? 6.6 mole. This is going to be your this is going to be the number of mole that you are going to find in them. And then the next part of it, now that you are going to do, after that, now you are going to do your O. Now we are going to do your oxygen, right? Now the oxygen that you are having there, you are given that your oxygen is given by 3.3%, and then you convert this 53.3% into grams. So this is going to be 53.3 grams, right? Then the next thing that you're going to do, you look for the molar mass. What is the molar mass of this? Your molar mass of your oxygen is going to be given by what? Your molar mass of your oxygen is given by 16. So this is going to be 16 grams per mole, right? And now after you've done that, now what is it that you're going to do? Now you're going to calculate what is the mole of your oxygen. And remember, we said the mole, it's mass over your molar mass, right? Now, which means now what is going to be the mass that you have converted there? This is 53.3 grams divided by your what? Divided by your 16. Isn't it so? And now then when you are getting that, you are going to find out that the mole that you are finding for your oxygen, it is going to be 3.3125. Yes, 3.125 mole. Please do not forget to write the mole. Okay? And now, as soon as we are done with this process, now you are going to look for the what? You are going to look now for the smallest. You are going to look for the smallest mole, right? You're going to look for the smallest mole, and then you're going to divide all these moles with your smallest mole, right? And now if you are going to check there, what is it that you are having? So the smallest mole in here, you are having 3.3, you're having 6.6, you're having 3.3125. So I think the smallest in here, it is going to be the 3.3. So you're going to come back here and say, now look, in here, for your oxygen, this is going to give you a ratio. Let's start with the proper one. The ratio, this is going to say, you're going to say, look, the ratio of this, your C, which is to H, which is to what? Which is to O. Now we are looking for the ratio, right? So this is going to be same as 3.3. And we said the smallest one is this one. So you're going to divide by 3.3, even this one. And what is it? The answer that you're going to find, if you are dividing there, you are going to find out this is the answer that you are finding here. It's 1. Right? And now we are continuing. What is this second one now? Your hydrogen. Your hydrogen, you're given that this is 6.6 mole, and you're dividing by the smallest mole. And what is the smallest mole here? It is 3.3. And when you divide 6.6 with 3.3, you'll realize that you are finding that the ratio here, the ratio that you're going to have, it's going to be 2. And after that, what is it that you're going to do? Now there you are having 3.3125. And I mean, approximately, now when you're dividing by 3.3, you are getting 1, all right? So which means the ratio here is to 1. And now, as soon as now you have that, so which means now your empirical formula, right? Your empirical formula that you're going to have here, the empirical formula that you're going to find here, it is going to be what? C, which means the subscript here, it's same as 1, the subscript here, it's same as 2, and the subscript here, it's same as 1, right? So which means this, it is going to be given by your C, right? This is going to be given by your C, and then this is going to be your H2, right? And your O out together. And you can write this in any order, right? In no particular order, right? So this is going to be now your empirical formula out together. Hopefully now this makes sense to you. And now after that, now let's see in terms of what is it that we can do now. What the next question requires us to do. Now look in 8.13. Now they say if the molecular mass of the compound is 60 grams per mole, calculate the molecular formula. I think you remember the concept. So which means now, remember when we started with your empirical formula, your empirical formula is this one. Now we want to find out what is going to be the original molecular formula for this. Now, and for us to do that, we are going to start here. Now we are going to take the empirical formula. Remember, we are having CH2O, right? Now we are going to firstly find out what is going to be your molar mass. What is going to be your molar mass of this particular thing, right? Of this particular formula. And your molar mass that you're going to find in here, it's going to be what? The molar mass, remember, you're having 12. This is 12 plus this is going to be 1, which is the molar mass multiplied by 2. Remember, you are having a subscript of 2 here, so you're going to multiply it by 2. Then plus what is your oxygen? Your oxygen is 16. So which means the totality of your molar mass that you're going to find here, this is going to be 13 grams per mole. This is going to be same as 30 grams per mole, right? And now for you to find what is going to be this, now we are going to say this is going to be same as now for you to find the formula or the molecular formula, you are going to say now your formula mass, this is going to be the formula mass now divided by the empirical mass, right? And now what is going to be now the formula mass, you are given that the molecular formula mass, it is what? It is 60, which means this is going to be 60 grams per mole divided by what? Divided by 30. And when you are dividing both of these things, what is the ratio that you are finding? The ratio that you're going to find, it is going to be 2, which means now from here, now what is it that you're going to do? You are going to say this CH2O is going to be multiplied by 2, right? The subscript. And remember the 2 that you are doing, it's you are going to multiply the subscript, right? So remember here, the subscript here, it was same as 1 and 1, right? So which means now your molecular formula, then now this is going to be your C2, this is going to be your H4, and this is going to be your O2, right? Does this make sense? Hopefully this does, right? And then this is how you are going to be in a position now to find or to calculate your molecular formula of your compound. And now this is when you are going to get now your full marks of this. Now let's look at now your 8.3 and see in terms of what does our 8.3 require us to do then. Now look, let's make up some space here so that we find out our 8.3. Now, look, in 8.3, what does 8.3 require us to do? They are saying now the molar mass. So they are saying now, look, you are having the molar mass of your hydrated sodium carbonate is found to be 268 grams per mole. The formula of the hydrated sodium, it is what? It is your Na2 CO2. But now one thing that we are not sure in terms of how many molecules of water are you also having here? So let's see the question. So the question also now requires you to calculate now the number of moles of water crystallization, which is the X here, which is the water that is formed as part of the product in the compound, right? Remember here we want to calculate what is the water that is formed, also the water molecules that is formed as part of your product. Now what is it now that we are going to do now firstly here? So now we are going to start here. Now, in order for us to do this, we are going to say now, what is going to be the mass? So we're going to start by calculating the your molar mass of your N2CO2, right? So we are going to say, look now, your mass of your N2CO2, which is your sodium carbonate, right? Your sodium carbonate, it is going to be given by what? Now, if you calculate the molar mass, I think by now you have an understanding in terms of how we calculate our molar mass. Now, the molar mass here, it is going to be the 23. I think this is going to be 23 multiplied by 2 plus what is your carbon? Your carbon is 12 plus this is going to be 16 multiplied by 3. And the answer that you are finding there, this is going to be 106 grams per mole, which is your molar mass of your N2CO3, right? Now, as soon as you do that, now, what is it that you are going to do now? You are also now, remember, you are given in terms of this is what is formed as the product, right? This is what is formed as the product. So you're going to come back and say now, how, now what is going to be now my molar mass? Or rather, what is going to be now my molar mass or of what? Of my water, right? Now, but remember the water, you are not sure in terms of how many molecules of water that you are having, right? You are not sure in terms of how many molecules of water that you're having. So you are going to represent this as your X, right? So this is going to be X H2O, right? Because you don't know, remember here, you already know that the ratio, or rather the molecular ratio, it is 1, but here you don't, we are not sure. But what you are definitely sure about is that now the formula, or rather the formula itself, or the entire reaction, it is given by what? It is given by 268 grams per mole, right? It is given by 268, and you know that the one that is formed by your sodium carbonate, it is what? It is 106, right? So which means you're going to subtract this so that you get what is the one now of your water. So the one of your water that is going to be used in here, it is going to be, I think this, let's punch in our calculator. We are getting 162 grams per mole, right? So this is going to be 162 grams per mole of your what? Of your water now, right? Now this is therefore going to be the mole, or this is going to be the molar mass of the water that is going to be used in here, right? Now that we found that, now we are going to continue and calculate. The question was calculate the number of moles. Look, now you have what is going to be your molar mass of this. Now we have the molar mass that is going to be in here, and what else now that you are having them, you can then now calculate the mole. And now you're going to say, for you to calculate what is going to be the mole, this is going to be what? This is going to be, let's see, now the mole that you are going to find in here, the mole, it's N. Remember the N of H2O, it is going to be given by the mass over your molar mass. Isn't it so? That is going to be what is given. And now to calculate that, what you are going to have is, now we are going to start here and say, now look, your mass, rather your mass that you are going to be having here, it is going to be 16 divided by what is the molar mass of my water now. Now that I have that, what is going to be the molar mass of my water? This is going to be given by 18, because remember, this is 1, which is 1 multiplied by 2 plus the 16, which you are getting the 18 grams per mole. And then the final answer that you are going to find here, this is going to be 9 mole of water that is going to be found here, or that is going to be formed here as your product, right? or so, which means now the value of your mole of your water that is going to be formed is going to be 9 mole, right? Now hopefully this makes sense to you. Thank you very much.